Okay, let's dive right into this. Welcome to the Explainer. Today, we are absolutely not just doing a dry, boring read-through of a syllabus. No way. We're taking this massive 60-page document from Cambridge and transforming it into your ultimate cheat sheet for the AS and A-level physics exams for 2025 to 2027. We are going to crack the code on exactly what the examiners are looking for, how they're going to test you, and most importantly, how you can use this very structure to strategically beat the exam.
Think about it for a second. What if you had the exact blueprint to your exam? Too often we spend hundreds of hours just memorizing physics formulas, literally shoving equations like F equals ma or E equals hf into our brains. But honestly, understanding exactly how the examiners think and how they build these assessments, that's just as critical as knowing the physics itself. When you actually know the rules of the game, you can play to win. And this Explainer, it's your roadmap to doing exactly that.
So, to make this easy, we're going to break this giant syllabus down into 5 logical steps. We've got 1, the Cambridge Physics Blueprint, 2, your course subject content, 3, the 3 assessment objectives, 4, breaking down the 5 papers, and 5, mastering practical physics skills.
Let's kick things off with Section 1, the Cambridge Physics Blueprint.
At its heart, the Cambridge Physics syllabus is built on 2 totally key concepts: modeling physical systems and testing those predictions against evidence. Physics is really the science of seeking to understand how the whole universe behaves. So you're going to be building models that simplify, explain, and predict that behavior. But, a theoretical model is basically nothing without real-world evidence, which is exactly why testing those predictions through actual experiments is heavily emphasized throughout this entire course.
Logistically speaking, Cambridge gives you 3 different routes to get your qualification. Route 1 is taking the AS level only, so just the first half of the course. Route 2 is the staged route. This one is super popular. You take your AS exams in year 1, and then you carry those results forward to finish your full A level in year 2. And then there's Route 3, the marathon, where you take all the AS and A level components in the exact same exam series. Figuring out which route your school is taking really helps you pace your studying right from day 1.
Moving right along to Section 2, your course subject content.
The whole journey is split really cleanly into 2 halves. Over in the AS level, you're covering topics 1 through 11. Here, you are building a rock-solid foundation in classical mechanics, stuff like kinematics, dynamics, forces, and waves, along with your very first real taste of electricity and particle physics. Then, if you're doing the full A level, you dive into topics 12 through 25. And guys, this is where things get really exciting and abstract. You transition from those foundational mechanics to the advanced, mind-bending realms of motion in a circle, quantum physics, medical physics, and even astronomy and cosmology. It's literally a journey from understanding a simple falling object all the way to understanding the Big Bang.
Which brings us to Section 3, the 3 assessment objectives.
Now, what's really interesting here is that the syllabus explicitly states you are graded on 3 assessment objectives, or AOs. Let's strip away the jargon and call these the 3 skills you need. AO1 is pure knowledge and understanding. So can you recall facts, laws, and definitions? AO2 is handling, applying, and evaluating information. This is your problem-solving objective. It's not just knowing the formula, but actually translating information, manipulating data, and constructing arguments. Finally, we have AO3, experimental skills and investigations. This is all about your ability to plan experiments, collect data, and analyze the results. And actually, taking a quick pause here, shifting your focus from just AO1 memory to AO2 application, that is hands down one of the absolute best A-level exam tips for all subjects, not just physics. It's exactly how the examiners separate the good students from the truly great ones.
Just look at the breakdown. Notice how AO1, just knowing the facts, is only 40% of your grade. AO2, applying those facts to completely new problems, is also 40%. You simply cannot just memorize your way to an A star. You really have to practice the application. And check this out. Experimental skills make up a massive 20% of your final grade across both the AS and full A level. So for sure, you absolutely cannot ignore your lab work if you want to crush this.
Let's look at how this plays out in Section 4, breaking down 5 papers.
All right, for the AS level theory, you've got Paper 1 and Paper 2. Paper 1 gives you 1 hour and 15 minutes to tackle 40 multiple-choice questions. Paper 2 is also 1 hour and 15 minutes, but it's worth 60 marks and consists of structured, written questions. Now, these 2 papers test the AS syllabus content, those topics 1 through 11 we were talking about earlier. And they heavily split their focus between your basic knowledge, the AO1, and your application skills, the AO2.
Then we meet the absolute heavyweight champion of the exams, Paper 4. This is the A-level structured questions paper. It is a grueling 2 hours long and worth an incredible 100 marks. Now, I gotta give you a crucial warning straight from the syllabus itself. While Paper 4 focuses on the advanced A-level topics, it explicitly requires assumed knowledge from your AS-level studies. So you cannot just brain dump your AS notes after year 1. No way. You are gonna need that foundational knowledge to solve the complex problems they throw at you in Paper 4.
Finally, we have Paper 3 and Paper 5. This is where that huge 20% experimental weighting comes into play. Paper 3 is for the AS level, and Paper 5 is for the A level. They both test your AO3 experimental skills, but they do it in completely different ways, which honestly catches a lot of students entirely off guard.
Which leads us perfectly into Section 5, Mastering Practical Physics Skills. So the crucial point here is understanding the stark contrast between these two exams. Paper 3 is a real hands-on, timetabled laboratory exam. You will actually be in a room with physical apparatus, micrometers, voltmeters, stopwatches, the whole shebang. You have to independently set up experiments, collect raw data, plot graphs, and evaluate your method. But on the other hand, Paper 5 is a written exam. You don't get any lab facilities. It focuses purely on higher-order cognitive skills, planning complex experiments from scratch, analyzing given data, and deeply evaluating uncertainties. And here is a massive pro tip for Paper 5 directly from the Cambridge documentation. You literally cannot fake this paper by just reading a textbook. To successfully design an experiment, pinpoint your independent and dependent variables, figure out how to keep everything else safely constant on paper, you need extensive prior lab experience. You need to put in those hours in the lab making mistakes so you actually know how to write about avoiding them when you sit down for Paper 5.
So why go through all this rigorous theoretical and practical testing? Well, as the U.S. Higher Education Advisory Council notes, these specific qualifications prepare students incredibly well, because they force you to go into a subject in considerable depth. You aren't just memorizing trivia, you're actively learning how to handle data, solve abstract problems, and rigorously apply the scientific method. Mastering this blueprint really gives you a massive, globally recognized advantage for university admissions and way beyond.
We've cracked the code. You now know the structure of the topics, the deep difference between testing knowledge versus testing application, and the absolutely critical importance of your practical lab hours. You've got the exact blueprint the examiners use. So the only question left is, how will you use this to build your mastery of the physical universe? Start organizing your notes around those 3 assessment objectives today and approach every single lab session as prep for Papers 3 and 5. Thanks so much for joining me on this explainer, and good luck with your studies.